Let's review distributive property and combining like terms. Distributive property questions look like this. And all the distributive property tells us is that I can either add two terms together and then multiply, or multiply two terms and then add. Both should get me equivalent expressions. So let's see what that looks like. If I were to add these two terms together first, I would get 2 plus 3, which would be 5. And if I then multiply 5 times 5, I would get 25. I can get the exact same answer if I multiply first. If I multiply 2 times 5 and then add my answer to 3 times 5, I should still get 25. We know that 2 times 5 is 10, and 3 times 5 is 15, and if I add them together, I get 25. So it doesn't matter if I multiply first and then add, or if I add first and then multiply. If both terms are being multiplied by 5, I can do it either way. So why does that matter? We use the distributive property for expressions with variables. So for instance, if I had an expression such as this, I would not be able to add before I multiply. I don't know what y is. I can't add an 8 and a y. They're not like terms. That's like trying to add a cat and dog. If I have 2 cats and 1 dog, I can't add them together and say that I have 3 dogs or cats, right? They're different. They're not the same thing. I can't get a total of cats and dogs together when they're 2 separate creatures. They're not alike. I have 2 cats over here and 1 dog over here. I can't put them together. It's kind of the same thing with a y and an 8. They're not the same. I can't add them. Since I can't add a y and an 8, in order to simplify this expression, I have to distribute. I have to multiply the number outside of the parentheses by both numbers inside the parentheses. I have to distribute or pass the 2 through the parentheses. So I'm going to do 2 times y. And I'm going to do 2 times 8. When I simplify that expression, I end up with 2y plus 16. This is all there is to applying the distributive property, multiplying everything inside the parenthesis by whatever is outside the parenthesis. Let's take a look at a couple more examples of this. In order to do this problem, I need to multiply both terms inside by the number outside. 5 times x plus 5 times 2. This gets me 5x plus 10. What if I had an expression such as 2x times 3 plus 4y? Same concept. 2x times 3 plus 2x times 4y. Now, 2 times 3 is 6, so this is going to get me a 6x. Plus 2 times 4 is 8, and x times y is simply xy. In order to apply the distributive property, all I do is multiply. Now, what about combining like terms? As we've said before, in order for me to add terms, they have to be alike. So look at this. I can take the things that are alike and get a total. So for example, I have 1, 2, 3, 4 x's, and I can put them in a group and say that is 4x. I can combine them and say in total I have 4 x's. I can't put an x and a y together and say that I have 2 xy's. That's not true. I only have 1 x and 1 y. They're not the same thing. In order for terms to be alike, they either have to be the same variable, such as an x or an x, or they have to both be constant terms. When I say a constant term, I mean just a plain old number like a 3 and a 2. I can add a 3 and a 2 because in reality, they're just groups of 1. 3 is just 3 ones, and 2 is just 2 ones. And I can add that together to get 5 ones. Just like this is 1x and this is 1x, and I can add that together to get 2x's. So like terms are things you can add or subtract from each other, and in order to be alike, it has to be the same variable or constant terms. Let's take a look at a couple examples of this. In this expression, I see two terms that are alike. I see 2x's. If I add 2x plus x, I'll end up with a total of 3x's. So my expression then becomes simplified to 3 plus 3x. Because this constant term has nobody like him, there's nothing we can add. Likewise, in the expression underneath, I have two x's that are alike, and I can add x plus x to get 2x. There's nothing I can add to my constant term, so I'm just going to leave that alone and rewrite my expression as 2 plus 2x. In this expression, I have an 8w and a w. I can add those together and do 8w plus w to get 9w. Now, notice that in this expression, I have two constant terms, a -2 and a 7. I can combine them by doing 7 minus 2, and that's going to get me a 5. When I rewrite my expression, I end up with 9w plus 5. Take a look at this expression. I have a 3w and a 2w, so I can combine 3w plus 2w to get 5w. I have a plus 5 and a minus 3. I can combine them to get 5 minus 3, or 2. This expression simplifies to 5w plus 2. Remember that in order to combine two terms, they have to be alike, either the same variable, such as an x and an x, or constant terms. Let's look at another expression. Look at this expression. Which terms are alike here? I see a 2y and a 5y and a y. 2y plus 5y plus y is 8y. I see an 8 and a 3. These are both constant terms. 8 plus 3 is 11. Finally, I see a minus 3w and a 4w. 4w minus 3w is 1w. And remember, we just write 1w as w. When I take all these answers and put them together in one single expression, I simplify this whole big ugly thing into the expression 8y plus w plus 11. And that comes from simply taking everything that was alike and combining it. Let's take a look at one more example of something we might run into. We're looking at all the expressions that are equivalent to 2k plus 2 plus k plus 3 plus 2k. So first, I'm going to figure out what terms are alike. I have a 2k, a k, and a 2k. If I combine them, 2k plus k plus 2k is going to get me a 5k. Then I have a 2 and a 3. And of course, if I combine that, I'm going to get a 5. So this whole expression can be simplified into the expression 5 plus 5k. This first expression shows me 5k to the 5th power. Remember that an exponent, like k to the 5th power, means that I'm multiplying k times k times k times k times k. We're not multiplying any k's here, we're adding them, so this expression doesn't work. Since this exponent doesn't work, of course this one's not going to work either, so that guy's also not an option. This expression is literally the one we just came up with, so of course we're going to go ahead and say that that's equivalent. What about this guy? This reminds me of distributive property, and if I distribute this 5 through my parentheses, I can see that 5 times k is 5k, and 5 times 1 is 5, which means that these two expressions are equivalent. So as you can see, for a question such as this, I will need to be able to do both distributive property and combining like terms in order to answer such a question. These concepts might seem a little challenging, but with practice, you'll be a pro.